Every Wednesday. Recording in progress. Thanks for coming back. We're gonna do a couple minutes of logistics real quick, and then we'll get started. We have a bunch more great presentations in today's sort of the fun quick bites, lightning talks. We have a bunch of those for you. So in terms of logistics, the only things to mention there, for those of you who signed up for the tours, if you're on the Harvard Art Museum tour, the tour leader is actually going to meet you in front of this building and then take you over to the Harvard Art Museum. For Houghton and Widener tours, you go to those libraries if you signed up for that. And the Leventhal Map Center tour, you should have gotten information from me about how to get to the Leventhal Map Center, which is just a short train ride. But if you have questions, come find us during a break. And the last thing, we should have thought of this yesterday when it was beautiful and sunny, but we'd like to do a photograph if you're comfortable. So real quick at the lunch break, we want to just gather on the steps, take a photo of folks. It'll take just a few minutes and then release you all to your lunch destinations. But I think that is it in terms of logistics. Anything else? Okay. In that case, let's get started. Welcome, Frederic from Ghent Center for Digital Humanities, and to kick us off. Thanks.
Good morning, everyone. I'm Frederic Lamsens. I'm software developer at the Ghent Center for Digital Humanities at Ghent University. I'm here on behalf of my colleagues, Fien Danniau, who originally wrote the project proposal. There's Vincent Ducatteeuw, and there's Lise Foket, who you saw probably yesterday. About Gemapt. Gemapt is a cultural heritage project. It is funded by the Flemish community, and we're currently working with 8 partners. Just to mention some: the Ghent City Museum, the Industrial Museum, the Institute of Social History, Museum of Daily Life. We have support from our Central University Library, so some other partners. Gemapt, the main idea behind it is we would like to use, or we try to use, places to organize, present, and explore history and cultural heritage collections. So if you think of streets, parks, waterways, shops, buildings, bars, musea, whatever, each of these places has its human history, and each of these places is linked to cultural heritage. So why not try to use places as a way to organize digital collections spread over different institutions? So, and by adding another layer, by using historical maps, we make it fun to explore a city, its history, and its collections. So, but first, to do that, institutions have to share their cultural heritage. And a lot of GLAMs at Ghent, they had a lot of work digitizing their material. There's a lot of work going into providing metadata to help discover collections. And of course, to publish your results, you try to adopt open standards. And of course, this is where IIIF comes into the picture. Unfortunately, at the start of this project, Flemish GLAMs had a varying level of IIIF adoption. There would be a scale from 1 to 10. I think 0 would be the most prominent number. So we had a lot of work setting up this project, a lot of promotional talks. So how can you promote IIIF to these GLAMs? I don't want to sound as your door-to-door IIIF seller, but when you talk about IIIF, you end up talking about standardized access to digital objects, shared digital objects, ways to display your resources, adding storytelling, annotation, participative enrichment, and collaborative learning. Now you can talk as much as you want to, but in the end, the question stays, how are we going to do all this? How can we be of help to these GLAMs to make their transition into IIIF? And moreover, how can we build something to prove everything we're talking about in a single application? So what we did was build a proof of concept, which we called Ghent Maps, to merge all their digital content in one application. So instead of do the talking, I'll try to give you a demo. I don't risk to give a live demo. Some of the resources are only visible in Ghent University networks or are behind authentication. So let's see if this works. So here is the a part of the map of Ghent. We've added some locations, streets, public places, each have their own icon. We added geometries. You can click on a street and explore description, digital content. So images coming from different collections. We use Mirador to display everything. So you can go through the different images. Another example is coming up, I think. Another street, so the Lammerstraat, which is a lot of shops there. Now we have a look at the Vooruit, which is a place where a lot of festivities, a lot of activities going on. So we're not only interested in having images of that place, we're interested in the history of that place and what was going on at what time at this place. Another example is our famous book tower. Dries, this one is for you. Now, if you have a look at King Albert Park, you'll see in the images we have about that park that it wasn't always a park. There used to be a train station there. So many people don't know that. But if we have a look at a different way, so we activate the historical map, you'll see clearly that there was a train station at that place. So you see, the structure of the city in that region hasn't changed a lot, but the way the park was, it's completely changed in the last years. Another view you have is the Muink Park, it's central. We don't have images of that park yet, but it was there 100 years ago. But if you look even further back in time, you'll see that there was a zoo over there. So the structure of that part of the city changed a lot. So we're displaying a current geometry of that place on a historical map. It introduces problems, but we can go back in time and show you information about that zoo. So we don't have pictures of it, but we have sketches of it, drawings of it. So we can explore the history of Ghent in an interactive way. There's a lot of fun playing with the slider. You can see what place appeared in time, when it disappeared in time. So we're only showing a small region of Ghent, only, I think, 140 places. I think in September this year, we would like to scale that up to more than 1,000 places. So we're still working on the data. So in order to make something like that, you have to help your GLAMs into their transition to IIIF. So as I said, in the beginning of the project, only 2 out of 8 partners supported IIIF. And as you have seen in many presentations yesterday, it's a big step to get started with IIIF. If you use a simple manifest editor, you can create single manifest. But if you have large collections, you can have a really complex workflow generating your IIIF. As Dries told me yesterday, IIIF is good at hiding the complexity of the creation of the end result, making it look simple, but there's a lot of work going on in the back. So we were very fortunate to work together with the Ghent University Library as our IIIF partner in this. They have been front runners in IIIF technology for a long time. So they helped us with the image and metadata conversion for the different partners. And they hosted everything on their shared Canvas platform. So a lot of institutions got started with a limited set of their material, thanks to Ghent University Library. Now, in early this year, a new project got released. Its first release, which is called the Collection of Ghent. It's a €5 million project setting up IIIF infrastructure for city GLAMs. So instead of starting small, they're trying to migrate all assets from different institutions to one big IIIF infrastructure. They have a central metadata repository based on the Oslo standard. So every material you grab out of their infrastructure has structured metadata using one single standard. So, which is good. So in order to build an application like Gemapt, you need three things. You need places, you need your images, and you need your maps. So I'm going to go through how we got all our data. So first, places. We needed to build what we call a historical gazetteer. You can see, you can look at a historical gazetteer as a geographical dictionary. So it's a list of places with names, feature types. For example, is it the street? Is it the bridge? Is it the building? You have dating. You have to add geographical extent, points, geometries. Sometimes you add relational context. So sometimes a place was preceded by another place. Sometimes streets were merged into one single street in later in the history. So there's a lot of data modeling going on to create your historical gazetteer. But the most important part is every place gets its URI. So you can use this URI to link resources to places. So, and if you publish your gazetteer as linked open data, even other institutions can use your gazetteer to organize and link to your organize their content and link to your gazetteer. So gazetteers are excellent tools to organize content. Second, images. We currently, at the beginning of this project, there was a manual selection of digital objects based on place queries. So we would query the institution's dams, get lists of images that might be interesting to us, and then do a manual selection of that material based on availability, visual quality, or diversity. So you don't want to have 50 images of the same building. You want to have some diversity in your materials. So there's a lot of curation going on to add your images to your map. So currently we have 5,000 images for our selected set of places. Maps, historical maps. Currently we have 6 historical maps. We did georectification on high resolution scans using QGIS. As said before in the first Monday, I think, doing that is very time consuming. But on the other hand, we were quite picky about how we wanted to do it. Yesterday, someone said you only need 3 points to do a georectification of a map. Stephen, you know who you are. But if you want to add historical maps on an application like Gemapt, you want to be able to see how the city changed over time. So you want to map your streets, your buildings, your places as good as possible. So you were quite picky about which maps to choose. Like I said, like right there are many more maps available, but sometimes the source material is not good enough, or you have poor georectification results. Sometimes you have to stretch your maps too much, and the result is not sufficient. There's another question you could ask: should you show geometries on historical maps? Because a one-on-one mapping is not always possible, so it might be confusing to try to show geometries that were made on current maps on historical maps. So that's something we still have to figure out. One thing I didn't mention, we were half a year ago, we got in contact with Bert Spaan from the All Maps project. So of course, one of our future goals is to migrate away from QGIS work and transform all our historical maps to IIIF maps. As a platform, we use Omeka S. The Ghent Mapped project is not a big project. We try to use as much open source tools as possible. So we had a lot of experience with Omeka S before. So we use it to store our maps, our places, our resources, our collections. There's some excellent modules available in for Omeka S to store geometries, to produce IIIF manifests, most of them written by Danniau. So we're grateful for that. So on top of that, we built some simple APIs, a map API, a place API, some presentation API changes, so we can feed web application with our maps, lookup services for places, collection, generation of collection manifests out of existing manifests. And on top of that, we build a Vue.js leaflet bootstrap application. We used Manifesto to parse our manifest. So as much of we try to use as much open source tools as possible. So after all doing that, you end up with this Ghent Mapped. I'm always proud to see it, but not all is good, unfortunately. You saw that we do a lot of manual selection of images. You can do that for 140 places. You can do that for 5,000 images, but the minute you scale up, it's unsustainable. So manual image selection in the end is going to be unsustainable, I think. Manual mapping of images to places is unsustainable. So somehow we were trying to look at how could we get more out of our resources to automate things. So minimum information you need is dates. When you present your images linked to a place, you want to somehow sort your images based on date. It's not a nice visual presentation if images from different time frames are mixed. And then you need identifiers and metadata to try to extract the necessary information to map your resources, the resources you consume, to your places. So we were looking at what is possible with IIIF. So first, the nav date property. It can store date times. It can store incomplete dates. So we were hoping to use that to ingest dates. Unfortunately, many of our manifests don't use that property. So somehow it's easier to store your dates just in metadata fields instead of trying to produce a nav date property. So that was unfortunate. The nav place property, you'd hope that if you have a lot of manifests pointing to, with geographical information pointing to a place, you could use that information to map your resource to that place. But unfortunately, it's a quite new extension of the IIIF specifications, so there's no wide adoption yet. And then there's the metadata property. So it's a key value pairs intended for presentations only. There's no semantics, so you never know what you're going to get. You never know what data is in what key value pair. So maybe you shouldn't parse it. But so what's next? There's the see also property. So the see also property allows you to point to machine readable resources. So big array, you can parse JSON, XML, RDF resources, try to get your information out of that, and then build your application. So this sounds good. No, I always think of the one property to rule them all, but unfortunately, when you start parsing these external resources, a lot of code or extra code is needed to support all these different date formats and date structures. So in our case, Ghent University, for example, is exporting Mark XML. The collection of Ghent is has a GraphQL endpoint. The AMSAP institution produce a custom JSON format that you can parse. So it's hard to support all these different formats. And moreover, not all of these external data sources are always semantic data sets. So sometimes you need extra knowledge about these data sets to be able to parse them. So we ended up for each partner having some custom mapping config to know where to get what data we needed. And if you think of Gemapt, it's a very simple project. You only need dates and information about places. So what would happen if you would need more data than that? So it gets quite complex, quite easy. So just a simple scheme of our ingestion pipeline. So every manifest we consume, we upgrade it to the latest version of the presentation API. We try to extract as much metadata as we can use. First, of course, using machine readable sources if available, but in the end, we ended up trying to parse the IIIF metadata. Some IIIF resources only had metadata and no external resources. Then you try to map your resources to places. So based on the metadata, which is sustainable if possible, but sometimes we had to use external mapping data. So we had lists of this resource with this identifier we can map to this place. So this is not so sustainable. So in the end, you have a repository of references to external manifests linked to places and added with some additional metadata to present all these resources. Now let me talk some more about enriching IIIF conferences, enriching IIIF collections through Maddock. You've heard already a lot about the Maddock platform. I think there's been a lot of promotion here on the IIIF conference already. So it's developed by Ducatteeuw. We've been investing a lot in the development of the platform the last few years. So it's a crowdsourcing and machine-assisted IIIF enrichment platform. One of the nice things for us is it uses custom data models. So you can create data models for simple transcription projects, for annotation projects. You can add data models for structured entity collection like places, persons, whatever. Lately, they've added new features to do metadata enrichment. But one of the nice things is you're not limited to adding new data. You can link to external data sources. So one of the things we did is write a simple lookup service on top of our Gemapt gazetteer. So we can use that, all the data we have in our gazetteer inside Maddock to enrich our resources. So one of the fun things is Maddock IIIF goes in and IIIF comes out, which makes it quite easy to display enriched content. So we just, when you ingest a manifest into Maddock, you can have crowdsourcing around it. And in the end, you can see everything that has been done, everything has been validated through the validation workflow on your in your viewer. So you can view the updated metadata, you can view captured entities as annotations, and it's very easy to present enriched collections. Moreover, there is the very rich API, so you can, instead of getting IIIF annotations, you can get structured data. And in the future, we would hope to allow our partners to receive the enriched data and get it back into their collection. So there's a lot of talks will be needed before that is possible, but this is one of our hopes for the project. We already have a few use cases for the Meta platform into Ghent Map. So we have a nice, we have old postcard collections which could use transcriptions. There is a collection of porcelain cards where metadata could be improved, descriptions could be added. There is a collection of historical worker houses. We could use some geolocation. So we hope to do all that using the Meta platform. But of course, we could use the Meta platform to improve our own sustainability. So instead of, if we could ingest a broader collection of manifests into a Meta platform, we could collect missing dates, or we could use the Meta platform to map resources to places using our gazetteer, which is, this could be a simple schema to do all this. So a lot of work to be done, a lot of ideas we could try out with the Meta platform. So to end my presentation, maybe some future work. We could improve the pipeline for enriched manifests for each partner. So there's we try to automate as much as possible, but still a lot of work to be done. We can migrate, or we should migrate our maps to IIIF maps. And we are hoping to publish our gazetteer as linked open data for heritage. This is part of a PhD project by Vincent Ducatteeuw. So one of his questions was, could there be an extension to the IIIF standard to support linking manifests not only to places using coordinates, but using linked open data. So, that is it for now for me. I thank you for your attention. If you have questions, I'm happy to ask them.
That's wonderful. Thank you. And I will say on behalf of the MAPS group, I think they'd be very interested in talking to you about that gazetteer question. But are there other questions, Martine?
So two questions actually. Have you considered placing the images on the map as well, or is that out of scope for your project? And also, are you aware of the World Gazetteer? It's a linked open data, like collaborative thing. I haven't looked it up like thoroughly, but I think it might be of interest, like to use and collaborate with an external, more broad service.
Well, your first question, displaying the images on our map is out of scope for this project. So we wanted to use real places as the entry point to consult our collections. We thought if we put all the images just on our map, it would be too much dots to click on. So it was better for our presentation. I'm not a gazetteer specialist. My colleague Vincent Ducatteeuw is working on it. There's a lot of data models to create gazetteers, and his research is about these data models. So he's working together with Antwerp University, for example. They have their own gazetteer about Antwerp. Vincent is trying to create a gazetteer for Ghent. The funny thing is he's trying to use IIIF to create his gazetteer for Ghent, because we have an index of old places, and he would like to link his results back to annotations on a IIIF manifest, just to validate his results. So you should ask Vincent about the gazetteer. I can't answer that question.
Hi, thank you for your presentation. You were saying that you thought that having all the photos on the map would be a little bit too much like overstimulation. Having like abstracted them sort of a layer back, do you have any information about like how people are engaging with it? Like, are people really diving into each thing and spending the time to click through? Like, could you talk a little bit about even taking every point off the map and taking it back a layer, like how much time people actually are spending you know, like like researching each place or something like that, being able to use a tool like this? Thanks.
Yeah, good question. Since this is only a prototype, we haven't shared it. We haven't shared a public version yet. We're still using it to validate our own results, to show it to promoters and even future partners to show what we're doing. There will be a public release, I think, in September. So from September on, we will be able to collect that data. It would be a nice project on its own to gather all this data and do research on it. But for now, we don't do it yet.
One more.
Hi.
Hi, Steve.
Awesome talk.
My 3 points. Yeah.
Sorry. My question was, the interface you showed, have you thought or talked about how search might come into that in the future?
Not yet.
Let me know, because it looks
Yeah.
awesome.
Well, I was thinking search could be a part where we ingest our manifests, I think. Well, we can search through our collections in Amatic, in the Amatic. I'm looking at you and I'm talking about Amatic here. In the Gemapt platform, but it's just a local search. We're not using the IIIF search API to do that. We were thinking of using more of the IIIF APIs to get our to widen our manifests we can ingest in our platform, and then do the curation in, for example, Matic or in Amica itself. So as I said, a lot of manual work has been going on, and now we know there is a sustainability problem. We're trying to solve each of those problems in the future. So I'll know where to find you.
All right. Thank you, Frederic.
Okay.
All right. Up next, we have Patrick Cuba and Bryan Haberberger. I get the searching for a space for Paul Dunbar, I believe. Yep. Restoring a space for Paul Dunbar.
All right. All right, good to be here. I'm Patrick. This is Bryan. If you doesn't have his lanyard, it's hanging in the hotel room he checked out of. So if I haven't met you, I'm from St. Louis University. I work as staff there, building software and doing things professors ask, project consulting, things like that. We have a lot of internal and external partners. If you haven't met Bryan, I'm sorry you missed the conference yesterday, but it was great. And I think most of it's recorded. Our project's called Restoring a Space for Paul Dunbar. We'll get into a little bit of the details of why it exists and what it's there for. But the technological answer here is that IIIF's come to a point where we can finally get into some new collections. A lot of the things that we promised in IIIF when it first started are starting to happen, which is very exciting. Conventional collections have always been designed for dominant cultures. There's a focus on what do we have in our collection and how can we expose it and share it with others. IIIF has always talked about this magic of remote things. In the presentations, we always show how you take the one thing and take the image and you move it over and plug it in where it's supposed to live. And there's just not as many collections out there that actually do this. A place for this really is in some of the marginal collections. When you have things where there's meta studies of data that's out there, or you're trying to curate something that doesn't really have a Library of Congress subject heading. We recently had a photo collection donated that was historic photographs of men in white hats. There's some real gems in there, but you would never go to that collection to find them. But they should still be shared. They should be available. They should be accessible. And some of them have much more important reasons to exist, such as with Paul Dunbar. who during his life was at a point in history in the United States when there was not as much marginalization, and the community was very welcoming and excited to have him there. And a lot of the time since, he's been stamped down further and further. So IIIF really creates a way to represent these remote resources remotely and leave them where they are instead of a lot of the solutions that we've had. This is yours.
So now that he introduced Paul Dunbar to you, we'll go a little bit into him as a unique subject in history. So what you see here are the main goals, which I won't read point by point, but essentially what we're trying to do is undo that stamping down of Paul Dunbar. So he's been part of those collections, and we'd like to make a unique space for him, a individualized space for him, just as a study point for research and history. So in modern times, we do have the ability to undo a lot of this obfuscation around subject material. We want all the data and all the sources used to achieve that to be accessible and future-proofed. If so, it enables future research where Paul Dunbar can be the seed or the source or the focus. I'll say, that's something that can't be done overnight. That takes a lot of research, a lot of collaboration, technology, and just plain old grunt work. And that's my warning to say we sort of just started, so I'm not showing you a complete project quite yet. So to do that, we sort of track him through his writings through history. His poems are in a variety of publications, but he, like Patrick said, he's sort of stamped down in them. So you'd imagine he's in a publication like African-American authors, where he is attributed, but he's sort of buried in and is not his own concept. It's possible that his poems exist in other publications where he or his peers aren't even attributed. And that's sort of what we call like an intentional obfuscation, which we sort of want to move away from. Those collected writings span cross institutions and other collections. And we want them all to come together. So something that's lucky for us, a writer in their life tends to do more than just their work. They have a social life and other interests beyond just their research or their work. So for example, UDel, University of Delaware, has a collection of letters that he wrote between him and his sweetheart. They're sort of a stamp in time and place, and that gives us sort of like an example of how he writes, and may even contain some poems we could find. So in our application, you'll see here, this is just a really high level example of what we mean by where the different data points are and what we might mean by, well, when we bring them together to describe him, how can we do that? So it's just like a real high level hand wavy thing. So the unlucky part is those things are spread out. They could be behind paywalls or firewalls, all kinds of, all kinds of blocks to actually getting through this. So to properly individualize Paul, he needs like an online authority file, and he does exist in IIIF, so we have that. And then for the individualization to persist, the data has to persist. And so I'm going to go through and show you where some of that data is at right now and the way it's persisting and sort of how we're going to bring it together. So this is a poem, just a golden day. It's from the Dunbar Music Archive. So you can see here already we have multiple media types. We've got a transcription that's text, we've got audio. So we'd like to be able to have all of that when we go through this. Nope. There it is. So here's a published ebook. For the project, they created a TEI rendering of his poems and shared it with us, and we made it a web page, and not a beautiful one quite yet, but it exists as that web page so that we can link to it, right? And that's sort of how linked open data works. You need something to exist behind an ID so that we can link in to the sources. So it's just an example of one of the places. Oh, yes, and here's the dialect glossary. So he has a lot of dialect he uses, and so they have audio bits to hear the pronunciation and sometimes just an explanation of what that word actually means. And I'm of course not even going to try because I would butcher it. So here is the DLA poem collection. So this is in the Dunbar Library and Archive where they have a list of these poems, and more poems appear here than in the book. So of course, part of it is letting the book know these exist and having the book further inform the fact that these exist. So there's multiple places to go read it. So here we'll look at a particular poem. This is an actual screenshot from our app. Some of the stuff's actually working, yay. This one's a prayer. So you can see the connected content. There's one that's a GitHub to the Dunbar book, and then 2 links out to eCommons through University of Dayton. Often, you know, it looks the same and it's the same title, but it's because some of it is just the text and some of it is a performance, right? And if someone else is performing his poem, you know, it's a good thing to bring that in and have it collected together under the one item that it is. So as we brought up before, UDEL also has a collection of handwritten letters. You can sort of see just a small little slice of it up there that I have in the header for the page, just as an example. You know, it says Dayton on it, Ohio, timestamped, who it's to, all the good stuff. Oh, so like here's some more just of like the metadata. So not just the poem itself, but also like the metadata, we can bring it together. And then down there, you see the images we brought in. So now getting into the IIIF part, we allow you to take those images from those letters, and hopefully we'll have more sources and more poems into our transcription software we have called TPen. It's really good with line by line transcription. So you can come here and this will spit out a IIIF manifest that then has a URI. So it's something you can link to as a resource. And it gives description, further description to this primary source that is the letter. So you can see here, I came back with that image and someone had transcribed the first line. It's probably Patrick, as we're working on it right now. And so you can see how in this view, the transcription informs this letter. And you know, that's your classic power of IIIF move right there, which is great. So there's existing software for creating and managing and hosting collections that involve media like this, and that you can even collect and send out as IIIF. You know, we saw Digital eCommons and Omeka, OCL, C Content, DM, Drupal, all that stuff that's already come up. Some of those already include IIIF and linked data aspects. However, for this project, none of them really did the full thing of collecting it all together and sharing it back out. Some of it being IIIF, some of it not. So Patrick's going to go a little deeper into what we did with each piece to make it work.
Obviously, we're not the scholars working on this. We aren't the people with the credentials to curate a collection like this. And that presents a challenge because you have to get the right people doing the collecting, and you have to make it easy enough for them to do that. When it gets encoded, it's encoded properly for the application, but also properly for the academic history that you're creating at that point. So we looked at a lot of the existing solutions, and the biggest challenge that we had overall was that a lot of things required you to either create a copy where you're mirroring something yourself, or there was a difficulty in doing a crosswalk between schemas within the project itself. And so what we found was the IIIF tended to be a lot easier to work with. And my project leaders especially have gotten to the pace now. If you notice from the schedule, our deliverable at the end of this summer is data entry. We have to prove that we have data entry to aggregate all of these things and to clean the data on them and get them towards the public presentation. So one of the reasons why we're not doing live demo right here is that we don't have the public site that is bringing everything together and showing it perfectly. We have a bunch of sites that make us excited that bring everything together and show us the JSON file so we can go, it's working. So instead, what we've done with them is, as the researchers have identified areas, we've said, okay, here's something that we want to bring in. Here's a collection that we can take pieces from. Here's the type of thing that we want included here, but we haven't found it yet. So one of those examples is a listing of all of the places that are named after him, especially things like high schools and grade schools, things like that. They really want to have a map with all of that. And that project just doesn't exist. So as part of the consultation on the project, we need to tell them, this is fantastic. This is a great idea. You need to do the research part. And then we can help you with the, how do we actually get this into something that's out there and encoded. It's not as easy as just going on Google Maps, punching in Paul Dunbar * school. and seeing what comes back. So the existing collections, things like Omeka, things like DSpace, and well, you name them all. All of these places are fantastic for a local collection or something that you're hosting yourself. It's a lot harder to do the sharing and the aggregating between all of that. Further, one of their specifications was that it had to be permanent but not maintained, which is an interesting balance. It's not a spec that we haven't all run into, but a lot of what we had to do was actually remove dependencies and say, okay, this is going to be as close to just JavaScript and HTML. And when we do rely on an annotation server, there will be a group who's responsible for maintaining that, and it won't be something that you have in-house. So that we are able to use IIIF very easily in that way. With a lot of the others, what we've created instead are a lot of smaller data entry portals. So we'll say, this is one that we know. So the Ohio History Connection uses IIIF. They said, we'd love to have this collection, literally ran a query there, pulled down that collection and ingested it. And now it's part of the project. And it was a half an hour. It was great. But with some of the other ones, like the University of Delaware, they have a PDF up online in DSpace. So there was a lot of manual back and forth talking to their librarians and saying, is this something that you would allow us access to? Do you have an endpoint you would like us to use for a static image of one of these letters? And ultimately, they just gave us a dump and said, here, you can have all of these. I'm fine if you host them in TPen. So TPen is actually hosting the manifests that create that with all of the references back to UDEL for the original things themselves. So even the research tools that they get into, they want to be ultimately part of this. That should be very easy to get these records out and share them as well. When you have IIIF, you have collections, manifest, images, and performances. Some of the audio that you saw there is people performing, reciting the poems. Some of it is actually videos of presentations that have been done, interpretations of works, music, things like that, reenactments. So there's a lot of different things that happen around the IIIF side of it that is very easy to use, but it also creates the issue of a lot of different media types. So this is definitely a project where we're able to do a sort of iterative enhancement. This is one of those projects I believe people will come back to a lot, and there'll be a small project that someone will be able to do and say, I've got $8,000 to hire a few students and get as many of the Dunbar high schools identified on a map. And then can we include that in the DLA? So the big challenge for us, and something that IIIF has done a good job in helping us solve, is how do we leave the space for those things that we don't know exist yet? When you're working with these kinds of hidden collections, these marginalized populations, there's a lot of things that are unknown. We aren't only going to be dealing with things. The example we had at the beginning, his typewriter is something they really want to include. And they want to include his typewriter, which is not in Dayton right now. They want to, if they can, have a 3D model of it, which does exist at a different place because of a different project. They want to be able to place it in his mother's house where he used it, which is something held by the National Parks Department and is a location. And they have a 360 virtual tour of the house that you can go through. So you can imagine now the challenge of being a public user and trying to interact with that collection in a way that makes sense and to travel through. So IIIF, and more directly, the IIIF stories applications that have come out are the things that I think we're going to be leveraging much more heavily in the public interface than we are right now. But to do that, we have to be able to take locations, people, library records, physical books that have been digitized, and create IIIF wrappers around them and give them a place in the collection. So we have a focus in data management and enhancement as the two things that we're delivering this summer to them. The first is finding ways between all of the schemas. Everybody's gone through the pain of trying to parse a description field to extract dates or provenance and things like that. Trying to figure out, is this title the same as the name in this other area? And if they're different, why are they different? If there's no language assigned to it, is because there's no language, or because it's the default language, or the language should be none. We've even run into collections where there's dialect that will be used. The dialect glossary, he was a dialect poet, and in the dialect glossary, there's a lot of places where they had to make customized fields to identify how the dialect is presented. and then how it's pronounced, and then how you might search for it, because you're unlikely to search for a dialect word that you don't understand unless you see it in front of you. So the way that these resources are talking to each other and the way that you can move around and find the connections between them, even though in data we can make those two-way connections, in the user experience, a lot of times you wind up only being able to go one way cognitively. So being able to make sure that all of the materials are ultimately discoverable. We don't want to create dead ends where you found something interesting, but you can't figure out how to get out of it. Or orphaned resources where somebody's done the work. They've created a dialect glossary. They have done a performance of, there was a interactive performance with congregational hymns and things interwove between two students who were reading the letters back and forth to each other. It's fantastic, but how do you get into that? If you're looking for it, you go find it and you watch the whole 90 minutes of it and it's great. But is there a way in this collection to say, if you're interested in seeing somebody do a really impassioned reading of this, it's here. And I can point to it directly in this manifest that has the video in it, show you that clip. But I can also include with it the annotation and the commentary around it that can back out and explain how that fits in Dunbar's context itself. How does that fit into his life? What were they going through as a couple at that moment? Where was he? You know, you show that he's living here and she's living here. And these are the interactions that they're having. So you can start to get into the stories idea of that. So the enhancements, first and foremost, is attribution, not only to Paul Dunbar, but to the researchers who are doing all of this work. This is reliant almost completely in the early stages on work that's already been done as far as research goes, which means when we bring things in, they are not recognizable anymore. You won't know when you're reading the transcription, you know, in the public interface, it doesn't feel obvious. Oh, this image is extracted from a PDF that's being hosted at the University of Delaware. This title and description was created by a person who wrote a book in the 60s about this. This particular transcription here was a collaboration between 3 students who were hired just for this project to generate this digital content. But that there is an historic transcription of this that's not quite as good, that also exists somewhere else that we've chosen not to show you in the first instance because it's not as interesting, it's not as well done, and it's way less encoded. So being able to create a network of attribution that recognizes everybody who's contributed, but still gives the users something that they can actually consume is very important. Then the connections between those and how do we put those into a system that gives people something that's consumable and obvious without orphaning data or creating situations where we have to do a very heavy lift, a lot of extra work to get a new piece of something accessioned. Photographs, they've talked about going into creating curriculums with K-12 students and wanting to integrate some of the outputs of that. They've talked about community contributions. There's a lot of people who still live in Dayton, who have photographs, who have artifacts from Dunbar and his family, because it's part of their history, who would like to contribute to citizen projects, but those are things that have to be moderated that take actual real human work. Did you have anything on here you wanted to? You just got your name at the top. I don't know what that. Oh, good. And you say it.
Just to reinforce what has been said and reinforce what he said. IIIF is good at hiding that complexity, right? The whole point is the users shouldn't be experiencing that those came from all those places and that they're responsible for knowing that or responsible for knowing more to have to go to 5 different links to figure it out. So just wanted to reinforce that. That's a very good thing for us.
So if this is interesting to you or you're doing something similar, I'd be very interested in talking to you. In 2023, at the end of June is when we deliver the whole platform itself with the public interfaces to them. There'll be a release party. I'm sure you're all invited. Performances, food trucks, it's fantastic. The research team actually has a cohort that is going through and teaching aspects of this as we do it. And they've now had a few in-person festivals and things around it, which is amazing. This is a much bigger project than just this platform, but it's worthwhile. To Bryan's point, what we're hoping to do for the future is be able to reuse these similarly for things that are as difficult to pin down, but are spread out there where the research is already done, where there's already work, and you just need to do non-destructive curation and assemble something that can feel a bit more semi-permanent, that it's not just a paper, it's not just an exhibit that you do enough work to get the board up on the wall for the museum and be like, great, we did it. Or in some cases, trying to capture the work that's been done to generate that museum exhibit and not let them just, load it up and put it back on a disk or throw it away when they've already made those connections between where people were when they wrote letters and what other things were going on in the world at the same time. So our focus is definitely a very low tech, high complexity kind of solution to things. And so we have more things that we've built for our own ecosystem that we're making more generic as well. Rare Musers is giving some of the people who are using our annotation service the ability to do authentication, not within their own applications. We're trying to reduce as much as possible. So we've gotten it to the point where people can come in and host a new project on GitHub pages and still give people a login and still authenticate everybody at the user level and have things saved as linked open data, free, public, open to the world. Rare and Playground is something else that we've been putting the pieces together of, which is taking a lot of the things that honestly you guys have been showing and putting it in a place where you might be able to walk in with a resource and say, can somebody just hang on to this for me? Right, let this be here, right? The exhibit SO idea of have this object. I want to see what can I do with it. So we just hammer it with different tools. You find something you like, you go, great, save that. Now I'm going to come back and look at that later and try to load it somewhere else. And then the generic version of this is a sort of collection management, curation, and moderation, something that looks and feels a lot more like, Omeka S to the user, but which in reality is generating something that's going out all over the web, all over the shared resources and pulling it together and regenerating that exhibit experience for a collection that you don't own. Might even talk about inboxes. We got that. Yeah, we're close enough. I could go all day on that stuff. Please do learn more about Paul Lawrence Dunbar and what he's done in his life. The other information is on there. The University of Dayton Department of Music is spearheading this, but it is explicitly in their funding collaborative between the Parks Department, 5 or 6 different institutions. It is one of the neatest projects I've worked on in terms of people who are working very much in the community and people who are working very much on the academic side collaborating. So anytime you see somebody tweet something about it or it's out there, follow up, because you'll be amazed and you'll want to do something just like it for your own local heroes.
Couple minutes for questions.
Yes, Bryan has a question.
Bryan, do you want the mic? No, thanks very much. It sounds fascinating and a great template for other projects. I believe you said something about 3D and 360. Can you say anything more about that? And are there some synergies? The interface you seem to be concerned about.
Yes, I would love to say more about that. In a lot of these cases, what's happening is the wish list is coming in and we're turning it into specifications and then saying, okay, what do we actually have? What do we have to generate? And what is the lowest level thing that we can do? So a lot of the yes and no's that we're giving to the project team are about what's available to them and what is likely to not be something that they have to maintain or that needs to be replaced 3 years from now. And so the yes group stays pretty small. There are some places that already have models shared of some of the things that they would like to be. There are already those digital resources out there, but the interfaces don't exist yet. So as this project goes forward, one of the things that we're doing is putting together the sort of shadow of what that would look like to be able to say, in the first instance, if you're on this record and you're in the DLA, we can tell you can go to this other site that has their own self-rolled 3D viewer that you can go through and see the thing in, and that's all part of it. And then the idea of the DLA is that slowly those shared resources will start to be visible in a single interface, right? And that's not always something that's going to happen right away or quickly. So we don't have a strategy right now to integrate those in the public interface, but that doesn't mean that by next June we won't.
And it's not like we have to develop a 3D viewer, right? If those 3D materials are there, I would say to the project manager, hey, there's this great thing called UV and version 4 was released. It'll show you your 3D objects. So part of my interface will just be a UV viewer, embed.
So obviously the 3D group would be interested in talking with you all, working with you all, and making sure that what works is repeatable elsewhere, because skinning and embedding and et cetera is going to be the name of the game, and don't want to proliferate beyond necessity. So just be interested in what you come up with and see if we can lend any experience as well.
Yeah, absolutely.
Absolutely. Yeah. And of course, we want this to be able to be repeatable for another individual, or maybe not even a human, maybe even just an object tracing through history.
Maybe one more question if there's one. All right, thanks,
Thank you.
Patrick, Bryan. All right, now we dive into a series of lightning talks. Let me make sure I get the right one, but I believe Cole Crawford, you're kicking us off? That's right. Yep. Yeah, talking about mapping color in history using IIIF Annotate to annotate historical objects with pigment data. All right, let me get.
Hi, everyone. I'm Cole Crawford. I'm a software engineer with Arts and Humanities Research Computing here at Harvard. I work with Rashmi, who many of you know from this conference or from her previous work on Mirador 2. And our group is dedicated to supporting digital humanities projects here at Harvard. We run the IIIF at Harvard site, and IIIF is really one technology that underpins a lot of the research projects that we support. One of those projects is mapping color in history. And Gina Kim, the project PI, is the George P. Bickford Professor of Indian and South Asian Art in the History of Art and Architecture Department. And we've been working with her and her research team to create an online portal for research into color. Gina started this project because she found that existing pigment databases were not ideal for art historians. They're centered around the pigment and the scientific data, and that is incomprehensible to a lot of art historians. So what this database does, this project, is it refocuses things on the artwork, and then it also brings in that scientific data. It makes the artwork the primary object analysis rather than the pigment. So we do use a lot of that same pigment data. It's been collected by art conservation scientists using like XRF for infrared or Raman analyses. And we go further by contextualizing all that pigment data through the artwork. So we have all of that kind of geospatial data that you just saw, temporal data, and plot all of these pigments on maps and timelines and things like that. Some of the project's challenges, one of them was our own IIIF infrastructure. I had a bunch of like small IIIF servers for various projects. So redoing that in a sustainable way was one of the things we wanted to do for this. A lot of the artworks were held by different institutions, some of which did not implement IIIF, so finding a way to still interact with those assets. And then annotating content, connecting annotations on these artworks to that pigment data. So we had a bunch of different outcomes from this. We wanted to be able to have researchers who don't know anything about IIIF easily IIIF content from all these institutions, annotate it. We wanted to reuse the IIIF infrastructure that we saw yesterday from our library technology services group, so that I don't have to maintain little image servers for different projects. I wrote some libraries to interact with those APIs, and then some things to make the annotation work possible. So we saw this part of this diagram yesterday from Katie. This is a lot simpler because with the APIs and all this infrastructure they wrote, I only have to think about the small ingest component bit. And I wrote a library that kind of wraps that, so future developers have to think about it even less. And that means that we can spend more time on the research project rather than thinking about IIIF infrastructure. They did all the heavy lifting. I get to think about how does this benefit researchers? So what does that like ingest process actually look like for a researcher? Gina's been going through, she's been securing all these rights from different institutions, and researchers can go to a work, edit it, and they'll create a new manifest. We already have a lot of the metadata about these works, so we wanted to reuse that. It's already stored somewhere else. We can have this kind of simple manifest creation workflow. And I was looking at the editor yesterday, thinking about ways we can already improve this. This gets sent off and ingested by the MPS infrastructure. Usually takes a couple minutes. So we have kind of status that we capture. It gives us a URN, a persistent identifier for the manifest, but all the assets are held by MPS, and so is the manifest. So we don't have to think about that. We just get a URL to display this. And then that shows up on the front end of our website here. And it's available for everyone to work with and view. So this is the ingest service library that I wrote to wrap all of this. This means that other projects at Harvard that are Python, Django based can really easily integrate this great infrastructure that MPS wrote. It means that they don't have to think about hardly any of this in like 30 to 50 lines of code. They can handle all of this. It can plug right into your existing Django file storage, and you just end up with a URN for all of your assets and manifests, which is really, really helpful. And finally, to talk about the annotations bit, this is still ongoing work, so it's not kind of completed yet. But this allows researchers to go and actually annotate these artworks and add pigment data. So they can talk about where did this particular pigment come from? Like what trade routes did it make its way to this artist through? And then we tie that back to the pigment data. So we say, this is the pigment that we think was used based on this particular chemical analysis. And we store all of that using CatchPy. That's an annotation server that was developed here at Harvard. If you were at the showcase on Monday, Annotations X, which Brandon Bentley talked about, it was originally developed for that. So kind of an annotation server that has this LTI component, but it's really extensible. So we're able to do things like tagging and threaded replies and things like that. So one of the things that I did was I built an adapter for CatchPy. So now you can use CatchPy with mirrored annotation, just like you can with simple annotation server and Annotate. And then, as you saw, also did some work to like add points rather than bounding boxes to mirrored annotations, and that kind of workflow for tying the data back, the pigment data back. And I think that's all I have time for.
Up next, we have John Moore talking about Miiify. I guess we'll find out. Distributed crowdsourced annotation.
Miiify. It's actually, I don't know if you remember the cartoon Miiify. Do you remember that? No, I just stuck with 3 eyes. It wasn't very creative. But it's Google unique, which is a useful fact. Yeah, so I'm going to not give a technical talk about the implementation. I'm going to try and do a more high-level version and the use case really for why I built the technology. So we're in GLAM, so we're a cultural heritage institution open to the public. So I'm interested in building public interactive displays that you can walk into and start to annotate content without having to have any user ID or authentication. So I would like to get to a stage where I don't care about who you are. That sounds bad, but I don't want to store your data. I don't want to have that kind of issue around holding personal data. So the idea is that the public walk up and interact with our image collections. And then there's quite a challenge with building interactive displays. We'd have to work with different teams. So we have, I'm in the research team, but we'd have to work with the estates and facilities team, the outreach and education team, and some other teams. So I thought, well, maybe that's going to be difficult to build and do a physical public display. So why not just do it in a 3D world instead? So the question was, you know, can you emulate like a physical interactive public display, but in a 3D environment? So taking a IIIF experience into 3D, but for annotation of images. And actually, Ronald's already talked about this, so he's ruined this bullet point for me. But Mozilla Hubs is like a really interesting project that allows this kind of interaction where you just need a web browser. So it's lowered the barriers to entry to start to interact in 3D. I'm not sure how ready it is for this kind of annotation type use case, but I haven't used it yet. So that's something on my list to start to investigate. But other options would be Unity or even Minecraft, but I can see the school kids just destroying everything when I build it. So I haven't figured out how you lock down Minecraft, but maybe we can build this in Mozilla Hub. So that's something I'm interested to work with. Anyone who's interested to work with that. So the challenge still remains, though, if we build it in 3D in a virtual world or in the physical real world, like who are the users and how do we verify the content they create? Because they're just walking up and interacting, and that's it. We don't know who they are. So it turns out this problem's been solved anyway. So it's a popular model on the internet for working with open source projects. If someone wants to make a pull request to my repository, I don't care who they are. I just look at the review. I review the code and accept it. I don't really need to know more than that, right? So there's a lot of ecosystems around this model. So GitHub calls it a pull request. So it's probably familiar to a lot of people here. And one of the sort of benefits of working with annotations is they're like code. So they're just text, right? So they're well suited to be stored into repository systems, and you can read and browse the text in a repository. So could we apply the methods of code review to image annotations if we tried to use this approach? So everyone I think is familiar with image annotations. This is just putting a bounding box. That's my desk with an Alexa on there. So I've just put a square around the circular thing, the Alexa, and tagged it and gave it a name. So when you go to view from your IIIF viewers, you'll get that information back. You've already seen all that kind of stuff here, so I won't talk more about that. So with annotations, you can store them directly in the manifest, but you can store them externally in a annotation server, and there's advantages and disadvantages for doing that. And so Miiify is an annotation server, but the sort of USP of it is built using exactly the same principles as distributed version control. And it's actually a simple concept. So if you're like into functional programming, it's the same kind of thing. It's like you take copies of data and you change those copies of data. That's basically it for like distributed version control. If you want to simplify, abstract it down to a problem. So more formally, Miiify is a W3C web annotation server. I mean, it's my interpretation of the standard, so there's still some work there to say it's a W3C compliant server. So I'm happy to get some help with that. It doesn't use a traditional database, so that's the kind of key. So it's very lightweight. It doesn't have any external dependencies. It actually talks directly to Git, native Git. So the Docker container is like 60 megabytes. It's very low in memory usage as well. And the idea is that you would deploy and share those annotations across deployments. So each of these physical or virtual displays would be backed by its own Miiify instance. So it's deploying copies of all the annotations across these virtual displays that get synchronized back through a central GitHub repository. And the main thing is that you get to utilize the review process is a nice functionality that GitHub builds in for doing review. So you get all that for free, and even APIs to automate. We even looked at the idea of using AI to do review. So, you know, if it's scaled to a problem, we could to a larger problem size, we could perhaps automate some of that review or flagging up some of the annotations. In summary, Miiify works on the idea of taking copies of data. That's pretty much the main principle. That data is mutated in isolation, but it's shared back through a review process. And it might not be important who made the changes or where those changes were made. Ultimately, a human or machine needs to accept those changes. More philosophical point, but who gets to decide what data has value? You know, we still have to go through that process. So as an archive, we will still need to create some of that content and decide whether or not it should go back live into the system. And that's it. And thanks for everyone here who started the GitHub repository. It was nice to see that. And to access it, you can just type Miiify in Google, because yeah, it's got 3 eyes. So you don't need a link. That's it. Thank you.
Right, thank you, John. Next, happy to welcome up Andy Cummins from COGAP to talk about an open source IIIF-enabled natural history collection platform.
Okay, I'll try not to. You said it now, so I almost certainly will. Hi everyone, my name's Andy. As Josh said, I work for a company in the UK called COGAP. I'm here to talk about a project we did with the Natural History Museum in Denmark. I'm probably going to talk quickly. A bit like John's talk, it's not super techy. It's more a call out to share this project, basically. So this community in particular is great at sharing these kind of open source tools and things. Not so great in other places, and we often get asked to open source things, and that's totally fine, but they often just kind of are hidden in plain sight on GitHub. People don't reuse them, and then we hear about somebody doing basically the same thing. It's a bit depressing. So please tell your friends, tell anyone you know, particularly natural history museums in this case. But as we go, you'll see there's some other areas where that might be useful. So the Natural History Museum of Denmark, it's relatively old, origins back to 1620. They've got a lot of stuff, and I think we've got about 400,000 items online. I haven't checked for a while, if I'm honest, but they're continually adding things as they go along. The context for us was we've never actually done a natural history collection before, but lots of art collections, archives, things like that, but not actually natural history collection. It's really complicated. It's got its own, whole domain expertise. We got under the skin of it, which is a fun thing. That's one of the benefits of working with various interesting institutions. But we really relied on our partners at the Natural History Museum of Denmark. It's a long way. That's called NHMD for now. But also their next door neighbor was very helpful, which I'll talk about now. And we had 2 distinct audience types. It's probably similar to a lot of you guys, but we work a lot with museums, so it's often experts plus general public. So it's about, hiding all that IIIF, just presenting things in a really nice way to, in this case, a lot of kids, things like that. And it has to be in 2 languages, Danish and English. So like I say, the next door neighbors were the Global Biodiversity Information Facility, or GBIF. At the beginning of the project, we started, the plan was extract information from their collection management system, do some stuff, present it in a nice way. But as we did our discovery, we found out about this, their next door neighbor randomly, and found out that they have a whole platform for doing this. It's a complex domain, like I say. They have it's an aggregator essentially for this kind of material. So we got in a room with them and talked about that, and you'll see how we did that in a diagram in a sec. The 2 audience types, we had to make it accessible. So there's a few nods to that. The main one being, obviously, the UI is easy to use and things like that. But particularly this language of the scientific language of of the experts does not transfer to me, for example, and other people. And so we were trying to figure out, if I wanted to search for squid, I want a squid to come back. That's what people expect. And with the collection information, that would not happen. Yeah, that's not how they refer to it. I'll just skip over that. Yeah, it's in Danish and English. Shout out if anyone speaks other languages and is into this kind of stuff. We'd love more languages to be added to the GitHub repo. It's relatively straightforward. There's not a lot of interface translation required, so that'll be helpful. This is roughly what it looks like. High level diagram. On the left, you've got Specify 7, which is a collection management system specifically for this kind of material. And then initially, we were going to have a line going from Specify to data store with probably some stuff in between. But we spoke to GBIF, and like, as an example, if you think about a robin, I think about a bird. In other countries, it's not a bird, it's something else. And GBIF do an awful lot of work around that kind of thing, about normalizing the names of things and enriching the material as it goes through, but metadata mainly. So we also found out that the museum kind of signed up for putting a lot of stuff on GBIF, and it hadn't really been happening as quickly as they wanted. So this was a good opportunity to kind of multiply the value of this project and say, well, if you want your super deep zoom lovely image on the nice collection portal that is pretty and everything for the the children, you have to put it in GBIF. And so it doubled up the value of this project. And I have to say this is like a phase 1 project, so bear that in mind when you see it. Yeah, so stuff published to GBIF. We found out that the vernacular stuff wasn't easy. GBIF didn't supply us with the right APIs, so we ended up implementing a little bit in the middle there that harvests nightly and kind of massages the information so that we can, allow things like this search to work. So this is what it's like. You get autocomplete, things like that. But maybe on this page, you see it a bit better. There, if we didn't do that vernacular search, you would have to know that Architeuthis ducks is what you're looking for. And, nobody's going to know that. Or, well, a lot of people are, but not a lot of the people who buy tickets to go to the museum. And then we also have other sort of nods to that. And on the top left, you can see some of the kind of the kingdom, phylum, class, things like that. You can kind of tell what some of them are: Animalia, Mollusca, maybe Cephalopoda. Once after that, where it starts fading out is where my knowledge starts fading out as well. So it's not on here, but I encourage you to go and look. But in various other parts of the website, there are kind of approximations to help you with that, where we've augmented that information with, cephalopod instead of cephalopoda. I just put this picture up because this is the freakiest thing I found. So this is my, I just think it looks like a potato product or something with teeth coming out, and it's an urchin. And if you go here, because of the vernacular stuff, you can tell that it's a sea urchin from Antarctica. So just to finish up, basically a call out to, if you know anyone who would be into this project, please tell them. Please tell them about GBIF as well, because it is absolutely incredible, but it is very science research focused. So what we were trying to do was bridge the gaps on that. In this case, it's a museum, so they have those two audiences, but they're doubling up of going through GBIF to this kind of platform. It just felt like a win-win, and it's there for other people to use. Another creepy picture, and there's some links to the project, a case study, and also the GitHub project as well. Cool. Thank you.
All right, and we have one more lightning talk before we do tea and coffee, which I see is already set up. This is from Jie Song, who really did try to get here, but was not able to get a flight out of China the last week. So we have a couple of recordings. A couple of folks similarly were not able to make it. But we'll start with Jie Song here, who is actually, I'll also mention, our ambassador to China, who's done a lot of great work. Coalescing the community there and hosting online presentations. And so this is what he had to share with us today.
IIIF helps LAM institutions in their digital transformation. It makes it easy to present, share, and annotate high-resolution images that your institution needs. I'm happy and proud to introduce E2, a command line tool to enable full-stack TripIIF capacities. E2 allows you to create adaptive TripIIF website with your local image files and share to the users internal or external to your organization. Focus on both usability and extendability. E2 empowers you to do image-intensive research in a private workspace on any operation system with TripIIF API 2 or 3 in any viewers you prefer, whether it's Mirada or Universal Viewer. E2 even gives you the power to share images on blockchain, namely IPFS, with your own gateway server, which is secure and free. E2 opens a whole new way to access images in local disk files and online TripIIF resources. And that includes completely dedicated TripIIF operation in self-serving manner with no need for any network access or the ability to publish your gallery on a durable serverless P2P network without a dime. As an E2 user, I can launch my TripIIF website by simply pointing out the path of my image file, and my folder contains images. That means all the laborious tasks ranging from pre-processing raw images, generating manifest files, adapting to TripIIF viewers, and establishing web servers are no longer on your to-do list. Your attention deserves itself in zooming in and out classic paintings, comparing versions of articles, annotating historic location in Middle Age maps, or transcribing characters from ancient scrolls, or on your own dataset, and expose them to a much wider set of users right away without a lot of additional work. If you have not used the TripIIF cookbook, E2 is a great reason to start with. Cookbook offer a rich set of recipes that are surrounded by sophisticated explanation on how to create a domain-specific manifest file in the different cases. Now, all these complex use cases are no longer static pages. E2 with the power of hot load under the hook enables you to modify cookbook in your favorite editor, such as VS Code, and instantly get the result in browser. That means you can play with TripIIF advanced features such as editing audio, video, captions, and subtitles, organizing multi-volume work with individually bound volumes, as well as displaying multiple values with language maps. They are not daunting challenges anymore. Users of E2 can browse your TripIIF content in the form of file package completely offline. While the power of import and export feature of E2, you have completely control over which image content together with which TripIIF manifest to pass to your audience. It becomes especially efficient when sharing large amount of data, considering the current cost and speed of USB disk compared with internet. Everything about sharing is under your control on your discretion. Your privacy is in your hand. Of course, you understand what P2P network means if you have been amazed by BitTorrent with its super speed in data transfer. No centralized server also means no cost involved. Furthermore, the ecosystem surrounded IPFS, which E2 leverages, connect a whole new world of the app with IIIF community. Transferring IIIF collections to NFT-based digital collections is just a few steps away. E2 is the result of collaborative work of IIIF community. Based on GitHub, we endeavor to contribute to global community by integrating more software from IIIF awesome list. So, if there are any image server, IIIF viewer, or IIIF content aggregator that are interesting to your need, feel free to open an issue or even make a PR. We are considering seriously about adapting them in the future version of E2. So, what are you waiting for? Give E2 a try today at GitHub. We cannot wait to see what you will take E2 next.
All right, thanks, folks. We're at our first break. There's tea and coffee there. It's looks like it may be less cloudy than it was, and we'll come back at 11. All right, welcome back. We're ready for our second block here. We have an hour and then we'll break for lunch. But to get us started, we have Julian Ramey talking about the Dash service platform in 6 minutes.
Thank you, Josh. Yes, hello everyone. My name is Julian Ramey, and I'm going to present some reflections. Really, it's not a product. It's not something fixed right here. So work about implementing the presentation and change discovery API for Dash, which is the Swiss National Data and Service Center for the Humanities. A disclaimer is that I also work for the University of Basel, which is the host institution for Dash. And in this context, in the context of a specific project, we are using the Dash service platform as customer. So you will notice with examples that these two different roles actually. So Dash service platform or DSP can be used for storing, sharing, and working with primary sources and data in the humanities. So DSP is designed to host and keep accessible, complex, qualitative research data. And to fulfill these requirements, Dash develops and maintains various software and tools that I'm not going to go into too much detail. But you can see that the metadata is stored in TripleStore, and that Dash has its own meta-ontology called the NORA-based ontology. To serve the data, mostly images, but also audio file, we use CP, which is compatible with the IIIF Image API. And as for the front end, while there is a generic user interface of this DSP app, the various projects and customers can and are encouraged to use the APIs to feed their own application. So as mentioned, the images are served by CP, and in terms of IIIF Dash, this is something that we've been providing under the hood. So most of the project, they don't know that they have something IIIF compliant. So you can see how the image API syntax is appended to our own set of rules, while the shortcodes for each project. And secondly, an experiment was conducted to dynamically create IIIF manifest if certain ontology properties were used to describe the images. But that's something that was quite experimental, and now we're trying to do something more stable. So as we already support the image API via the RSCP instance, the question remains how we could deploy other TruePath APIs. And there are actually here two scenarios. One is that we provide that support, and I'm going to show what I actually did over the past 2 to 3 months. So I had to start with the data that was publicly available, which was kind of difficult sometimes because like 3D or video data, actually, most of them are restricted. So it's not, we don't want to deal with that yet. So you can see that the boilerplate or the templates for TruePath do not exist yet. So I had to see the patterns with the NORA ontology classes and then create some manifests manually. So I largely made use of the TruePath cookbook recipe to create these templates, which are very useful. So for the moment, I hosted the JSON LD files in a GitHub repo, and you can see via the creation of a small TruePath collection. So later on, we're still on the single image here, everything's works. I mean, actually, it's pretty easy, thanks to those recipes, to create those resources. So either here you have the same actually series of images, and that was actually the only audio data that was available and not restricted that I have done this way. But the second scenario, which is also quite interesting, and here I switch roles, is the one where project members deploy the presentation API themselves because they have the IT capacity to do so. So within the PR research project, where we have the technical skills and time actually to do so, we want to build on top of the TruePath image API, and we actually have our own instance of CP at the moment, and we set up a host application based on Laravel, which is a PHP framework, to generate the TruePath manifests and the collection on the fly. So later on, we will use the CP instance of Dash when the database migration is done, which is always in the next 6 months. And that should not be a problem. So, but then comes the questions of which manifests are the source of truth. And in this case, we will have to cooperate closely with Dash, possibly with URL redirection, to avoid having competing manifests. But that's how actually we've been doing it. So there's a small demo of the script that creates TruePath resources and how they have been implemented for the moment. Have a look at the link later, but it's quite generic template, different routes, one for the manifest, one for collection. Later on, there will be one for annotation, annotation page, annotation collection. And then that's our prototype where you see that we have implemented those manifests. Problem is, if something is done one side, then they don't work. So, which is every weekend when the university thinks it's good to close every virtual machine for 5 minutes. And some quick thoughts about how deploying the changes to API. I must say that I haven't had a lot of time to do that, but we have an event log of some kind with different types of actions. And by combining these pieces of information with the generated TruePath resources, once it's actually automatically or semi-automatically done and not manually. So either via a new property without a NORA-based ontology or by storing them somewhere other than TruePath store, we should be able to create that activity streams for aggregation purposes, which should, we would make sense as we host projects from different institutions in Switzerland. So last slides. So this is something that would take still a few more years. We will see that we have different scenarios. And the PR research project is a good thing because we can see what could be done on top of it. But for most other projects, when it's done, then they don't have the IT capacity to do so. So hopefully by 2023 or 2024, I'll be able to present something that is more comprehensive to this community. Dash is intended to be kind of a living archive, so TruePath is definitely essential to us. Thank you very much.
Thanks, Julian. Next, we have another video from Joe Padfield, who again, at the last minute, basically wasn't able to make it here. But I think he's inadvertently pulled a fast one because I think he's
morning.
evocative.
My name is Joe Padfield.
proposal.
I'm one of the principal scientists working in the National.
All right. To swap, or I think the title is it time to swap image for information in IIIF? So let's see what he says.
Good morning. My name is Joe Padfield. I'm one of the principal scientists working in the National Gallery in London. And today I would like to thank the IIIF conference organizers for allowing me to present IIIF. Could it be time to swap the image for information? IIIF has been developing now for over 10 years, evolving from a collaborative method for presenting images on the web into a robust, well-documented global framework for sharing and linking images, maps, audio, video, and soon hopefully even 3D models. But with a few small adjustments, it could also be used to share other types of data or graphs, or even more. So at what stage might IIIF transition into the International Information Interoperability Framework instead? This lightning talk will introduce a new simple IIIF collection and manifest presentation tool based around Mirador 3. It uses the existing presentation API to link sets of images to PDF versions of related publications, but also explores how presentation API could be used to present simple interactive tables or even graphs, highlighting an interactive use case of why it could be time to swap image for information. For over 10 years, the National Gallery has publicly presented high-resolution images. These sets of images have been put together to provide additional content for exhibitions, publications, and research projects, augmenting the limited number and often limited resolution of the images that can be printed or included in print media. The old system, based on a bespoke IIP image viewer combined with a MySQL database, has been showing its age for a while. So as part of the recently finished AHRC-funded Practical IIIF project, work was carried out to update the system to exploit IIIF presentation version 3. The structure of the old system was based on a hierarchical group of images with titles, descriptions, and links. This was easily replicated using a group of 144 related IIIF manifests and IIIF collections, stored as simple JSON files. The presentation system was created using the Open Bootstrap toolkit, allowing users to easily explore complex IIIF collections and display actual images within Mirador 3. And there's the link of the live system down the bottom there on the right. Each IIIF collection or manifest could be used to generate a simple responsive page, which formats, displays, titles, comments, links, IIIF resources, and any additional metadata stored within each of the IIIF documents. With the included IIIF resources displayed either as an interactive list, as shown here, when at least one nested IIIF collection is included, or loaded directly into Mirador if only IIIF manifests are present. Now, these manifests are displayed as a list, as shown here, when there are multiple manifests included, or automatically opened up as a gallery presentation when only a single manifest is included. In addition to exploiting the benefits of the IIIF viewer Mirador, the system has also been designed to display relevant PDF documents next to the images, rather than just providing a link to the document somewhere else. In this case, the actual full article from National Gallery Technical Bulletin, volume 35. This is achieved by adding the PDF details directly into the IIIF manifest as additional metadata, which can then be read and processed by the presentation system. As the PDF is related to rather than a depiction of the presented images, the rendering field was not used, but obviously that it could be possible in the future if the scope description of the rendering field was altered. Now, additional metadata within the manifests and collections have also been used to define a breadcrumb trail for navigation. This is an area where we'd like to do some more work, as it's pretty bespoke at the moment. It might be interesting to see how a more generic solution could be developed. Now, IIIF collections of manifests work very well to represent most of the resources from the old system, but not all. One of the technical bulletin articles was linked to a table of data rather than images. So for this particular system, a slightly non-standard manifest document was created with type table, with all the actual table data included as metadata within the manifest. Here, the table is automatically presented as a simple bootstrap table to the right of the PDF article. And the Bootstrap table system automatically provides searching, reordering, pagination, and filtering. And obviously, in this case, with the small responsive screen, a very useful full screen option. So users can actually explore and read through all of the data included in the table. Now, equally, although it's not been done or not been implemented in this particular example, the data could also just as easily be presented as a graph, perhaps with type graph. Or future viewers could allow users to choose a presentation mode. So a single manifest could include images, data, tables, 3D models, and so on. And viewers could allow people to move between and present any of these types of information. So could it be time to swap the image for information to give us the International Information Interoperability Framework? We wouldn't even have to change the logo. So this system and this work has all been carried out as part of the Practical Applications for IIIF project, as I mentioned before, which is part of the Towards a National Collection programme funded by the Arts and Humanities Research Council in the UK. And down there on the right, we have a link for the Towards the National Collection website. And on the left there are 3 links, one to the live demo of the system I've just presented, along with the GitHub code repository for the software, and a link to the Practical Applications of IIIF website. Thank you very much.
Okay, thank you, Joe. Next, we have Michael Spalti talking about bringing DSpace or bringing IIIF to the DSpace community.
Okay. Hi, I'm Michael Spalti from Willamette University. I'm going to share some work that I did with Andrea Bellini from Forest Science in Rome, Italy. Bringing DSpace to the IIIF. I did the same thing, bring IIF to the DSpace community. So first, some quick context. To set the context, DSpace is widely used by research libraries as an institutional repository system for publications and research data. It does a lot and it supports a lot of file formats, but historically it has not supported images and sharing images that media particularly well. Some would say has not supported it at all. So there has been interest in IIIF in the DSpace community for a few years, and there have been some local implementations created. There's a commercially supported solution from Forest Science. I'm going to talk to you about a new IIIF integration that is in DSpace 7, the latest release of DSpace. These are fairly early days, as you can see. The initial release was in October of 2021. With support for Presentation API 2.11, Search API, which is Search API support, which is experimental at this point, but very close in Mirador 3. With the DSpace 2 release in February, we added some more workflow tools for batch importing and working with IIIF metadata within DSpace. There have been some small changes in DSpace 3, but not much at this point. I'm anticipating that we'll have full support for Search API search and indexing in DSpace 4, but we'll see how that goes. There's some discussions about architecture at this point. A quick overview of sort of how do you get started and how do you use it. There's some backend configuration that's available. First of all, you need to enable IIIF in DSpace, and then you can configure metadata fields and other things at sort of the global level on the back end, at the backend REST API. On the front end, is an embedded Mirador viewer into the Angular application. You have full access to Mirador configuration. So we have a default configuration and we support a couple plugins. You can disable those plugins. You can add other plugins as you choose. So everything is driven by metadata, obviously. So there's basically item level and what we call bitstream or image level metadata in DSpace. The item is just a bundle for the metadata and the images. And I'll show you some examples of that soon. We've, as I said, created some tools for working with that metadata for large collections of IIIF data. You can batch import, you can DSpace has some existing tools for batch editing and metadata. There's some new tools for setting canvas dimensions across all of your collections. There's, again, indexing support under development now, and collection templates are sort of a concept in which you can define required metadata fields for a collection. Any item that is submitted to that collection will get that metadata automatically, which is great if you have people submitting images and that you don't have to worry about enabling IIIF for that the image that they submitted, that will be done automatically through the collection template. And you can also manage all this through the administrative user interface. So we're gonna take a look at some of that now, try to make this clearer. You can see at the top, we have, this is an item level record, the metadata, Dublin core. There are a couple other schema in the metadata registry, and we're using a couple examples for those here. The first is the DSpace IIIF-enabled. If you add this metadata field, then that item is now ready to be used as a IIIF item. I'm also going to illustrate the search option. If this is in the metadata, then this record, the search service will be embedded in the manifest, and the Mirador viewer will have the search panel enabled in the view. This is the image level metadata. This is a JPEG 2000 image. You can see you can define the canvas label or not. DSpace will generate these automatically, sort of sequentially 1, 2, 3, 4. They can be page 1, page 2. If you want to change that, it can be item 1 or photograph 1. That's another metadata field I haven't showed you. It supports ranges. Again, obviously optional. I'm going to show you an example of a nested sort of table of contents range. And then canvas metadata. DSpace will guess, it will determine the dimensions of the first image and use that throughout the image, throughout the manifest for all canvases. If it's one image, that's going to work great. If you have lots of images, then this is not optimal. And we really do recommend that the height and width metadata be included in the bitstream, or excuse me, the image metadata. And this can be done, as I said, just through a command line or process that will do that for you automatically. We're going to now shift to look at the viewer. This is a multi-page document. Obviously, you can see that the search panel has been enabled because this item is searchable. You can see there's quite a lot of metadata for the image in this record, probably more than you want to see or users want to see. This is also configurable at the global level. You can show nothing, you can show it all. You can decide what metadata you want to show here. And our default configuration includes a navigation panel on the right. You can obviously change that in the Mirador configuration. What happens in this case, though, we decided this is useful, and it will disappear if it's a single image. So, again, this is configurable in any way you would choose to do it. And this is my example, my contrived example of that nested table of contents and ranges. Again, search is supported. This is an example of a search that was initiated in DSpace, the larger DSpace, on a collection or across all of DSpace. I selected the item, the search is then passed through to Mirador, and it opens to the page with the words highlighted, which is kind of essential, we think, for our users, certainly. So again, I do think this is real support. It works well. We just need to decide how to build it in and support it ultimately in the product. And obviously sharing is what this is all about. And so it does work. The classic example, but on the left is an image from DSpace from our local collections. On the right is an image from the Harvard libraries. Okay, I'm told it's time. So I have some plans for future development. You can glance to that quickly, and community resources. So thank you.
Great, thank you. Next, I'm happy to welcome Nick Lycona from Performance Software, talking about transcribing primary sources using fair copy.
Hello, thank you very much. Hello, my name is Nick Lycona, and I'm a partner at Performance Software Solutions. Our firm has been working with scholars in the digital humanities in North America and Europe for over a decade. At Performant, We view IIIF as an essential technology for our clients and the products that we develop. It links digital critical editions directly to the archives that hold historical and literary manuscripts. This democratizes the use of these materials in ways that we're just still beginning to explore. Today, I want to show you our latest product to use IIIF. It's called FairCopy. FairCopy is a word processor for the digital humanities. It provides a user-friendly interface to the guidelines for textual encoding, or TEI. By providing both a word processor style environment for transcribing in TEI and access to the world's cultural heritage institutions using IIIF, we really hope to open up who can create digital critical editions. FairCopy users can import IIIF manifests in both version 2 and version 3 of the presentation API. In TEI, the analog to a sequence of canvases is called a facsimile. Facsimile can have any number of surfaces, and these surfaces can have graphics. This may sound familiar. We generate this TEI automatically for our users and link the TEI at each level back to its corresponding URIs in the original manifest. Once the user has loaded a manifest into FairCopy, they can reorder the surfaces, remove surfaces they don't want, or change the metadata of each surface. They can also annotate the surfaces using Annotate's OpenSeaDragon plugin. The user can mix images from remote repositories with images from their local computer. Once a facsimile has been imported, users can display it in a side-by-side view with an editing interface. A facsimile is one of several resource types in FairCopy, all based off the TEI specification. There are also text resources, metadata headers, and standoff markup resources. FairCopy has support for most of the 500 plus elements in TEI. This allows users to encode a wide variety of texts for a wide variety of research questions and preservation requirements. FairCopy groups TEI elements into 3 types: structure elements, phrase-level marks, and inline elements. Start my video here. Structure elements are things like divs, paragraphs, and line groups. These structures can span multiple leaves of a primary source. TEI is organized hierarchically around these structures. The structures themselves can be linked to images or zones on images. Linking structures to zones on the image can be useful for texts that have complicated layouts and/or layered revision histories. Additionally, the user can specify language code at the structure level. If the specified language is written right to left, the editor will provide a right to left editing environment for text within that structure. In FairCopy, the user can apply a structure element to a block of text by simply dragging and dropping it to the appropriate place on the structure tree. FairCopy validates the placement of elements as they are placed, so it isn't possible to create invalid TEI while editing. Users can also create new blocks by simply pressing Enter, which adds another block of the same type. Phrase-level marks are used for textual features that are usually smaller than a paragraph, and these can include names of people and places, editorial marks such as additions and deletions, or text that may have been corrected by the editor. The user can simply highlight a passage of text to apply these elements. And for all element types, the user can add additional information in the form of attributes. And then these attribute fields have their own data types, which FairCopy also validates for the user. Inline elements mark a single point in the text, such as the beginning of a page. Page beginnings are often used to associate page images with the transcription in TEI. In FairCopy, if a link to a facsimile is provided, then a thumbnail of the page is provided in the margin, as you can kind of see there. And these thumbnails are generated using the image API. So you can kind of see here on this, where we are here right now, that's the purple kind of bars there, the hierarchical structure of the text. And then you can see various highlighting of phrase elements. And then when there is a link to a portion of the facsimile, then you see the image appearing there in the margin. And so here you can see the user selecting structural elements and dragging and dropping them into the structure of the text. And so, you can do sort of rich markup, both at a sort of structural level as well as a phrase level, and then link this to your IIIF sources, which are then in turn linked directly back to the host institution. Once you're done encoding your text using FairCopy, you can export them using TEI XML. We can group text resources and facsimile resources together with their respective metadata in a TI document resource. The page surfaces are linked to their respective transcriptions using relative URIs and XML IDs. The surfaces that we imported via TI are also linked to their original TI IIIF manifests. So if you're curious about fair copying and would like to learn more, you can check it out at our website there. And thank you very much for your attention.
Next, we have a video from Kiyanori Nagasaki from the University of Tokyo, who also was not able to join us, couldn't get a flight here, talking about means of improving annotations in video in Mirador.
Hello everyone, my name is Kiyanori Nagasaki, a researcher of digital humanities in the University of Tokyo. We deeply appreciate the organizers for providing us with the opportunity to present our work at this conference, while I couldn't go to the United States. This year, I will talk about an improvement for video annotation on Mirador. IIIF Presentation API version 3 provides a remarkable improvement to embed annotations to timeline. However, software implementing the specification was not sufficient for video annotation. We needed to easily add text and images as annotation to video. So we aimed not to build a new viewer, but to add the function to an existing comprehensive IIIF compliant viewer. Among the 4 famous viewers, we selected the Mirador because it's available for video in version 3 and has good functions for annotation to images. The implementation was almost conducted by Jun Honma, who is also a developer of IIIF Creation Viewer. It's first time for him to improve Mirador, but he has much experience on developing IIIF applications through development of the IIIF Creation Viewer. So we'd like to explain our improvement from this aspect, that is interface, availability, and the feature. Regarding the interface, we adopted the treatment of the annotations on Mirador, such as listing on annotation panel. When user clicks an annotation on the annotation panel, the video moves to the annotated time frame. A target of an annotation is shown in the form of a rectangle like this. At the bottom of the video screen sphere, we added the video control panel with some basic functions, such as play and pause button, slider, volume slider, and the button to switch the videos included in the manifest. Regarding availability of our implementation, we can annotate a fragment of a text to any portion of the video screen at any given time. And we can also annotate an image file instead of a text. Here's an example of text annotation. Under the key of annotations, annotation page is listed. Each annotation is embedded to the annotation page, like this. The text annotation is here as a value, and the coordinate and time duration of the annotation is added in compliance with the media fragment URI, like this. This is just compliant with IIIF Presentation API version 3. Here's an example of image annotation to the video. The media fragment URI is same as the text annotation. The type is different, and the URI of the embedded image, in this case, this arrow, is included like this. And the motivation is also different here. The example is displayed like this. This is the example of a bird touch the ground. Then a handball touch the ground here. Then impact. Pause, and then we can back to here, here, and here. Please try to use it from the URLs. Another example indicates a possibility to use an old video with less expensive cost, not by using video software, but by editing JSON data. Regarding the future of our implementation, actually, this matter is not a feature, but the present. The latest version of it allows users to attach web VTT for compatibility with ERA. The tutorial has not yet been prepared, but you may try to use it. The version was presented by Yona Takahashi and us in Japan. It will be done in an international meeting by him in the near future. And then, in the future, we'd like to put audio, video, and hopefully 3D object on the video screen. We've not yet found a good validity to implement it so far, but we'll do it in the future if other good solutions will not appear by other ones. Thank you very much again for giving us this opportunity to present our implementation. I hope that this wonderful IIIF community will grow and develop further. Thank you.
Thank you. Up next.
Up next, we have Alec Vandenbroek talking about enriching art with IIIF.
Thank you. First of all, I'm honored to be able to speak here today at IIIF conference. I'm going to talk a bit about how I used IIIF to visualize my results from machine learning to make art collections more searchable. But first off, I'll start with a slide introducing myself a bit. I'm a computer science engineer, specialized a bit in artificial intelligence. I'm currently doing my PhD at Ghent University with IMEC ID Lab and Ghent Center for Digital Humanities. A couple of my colleagues have been here and have already done some great presentations. And I'm currently working on the VKC Enrich project for the Flemish art collection, which some of you might also know. So the data that I'm working on are salon catalogs. So they're art exhibition catalogs for art exhibitions held in Ghent, Antwerp, and Brussels over an extended period of time. The nice thing about them is that they're relatively well preserved and mostly digitized, but not all of them are IIIF digitized yet. The hard part is that they're distributed about over a number of institutions, so it's been a sort of a struggle to get them all together and on one line. And like the valorization of the project is the fact that a lot of these artworks are in the Flemish museum collections, which is nice to get like the metadata from the pages. So these are some examples from left to right. From the left is the oldest one, the right one is the most recent one. So you can see there's like a lot of difference in not only in quality but also like in terms of color. So yeah, it's not as complicated as some of the diagrams you have seen, but basically we start by converting the PDFs that we get or to images. In case of IIIF manifest, we just extract the images from there, and then we go into a lot of machine learning, which I'm not going to bore you with details. And then the results from all these machine learning techniques get sort of put into a manifest, which we can then validate or sort of improve on through the use of malloc. And then we try to let this information flow back to the original system. Sadly enough, at this point, we're only doing the machine learning part yet. So we have some really nice results, but I've already done some proof of concept, which is shown in this slide. It's maybe the most interesting slide of all of them. So as I told you, I'm like a machine learning engineer. I like doing machine learning. What I don't like to do is do a lot of visualization, making websites. That's not where I'm really strong at. So that's where IIIF comes in for my project and really sort of facilitates that process for me. So as you can see, page at the left, it gets split up in like a lot of different text sections. We can also then semantically go to sort of annotate them and say like the upper line is information about Marcel Duchamp, which is a name that has already been dropped, I think, a couple of days back. Then we can OCR that part of the image, get some text, and then we can do NER on it. So sort of give a semantic meaning to certain groups of words or just words in general. So Marcel Duchamp is a person, for example, and then the OCR, we can embed the OCR into the IIIF manifest through the see also property. The NER results we can just use as annotations because those are really interesting and should be visible on the canvas directly. And then you can, in the later phase, we plan to add like IIIF search API, which should enable us to like really search effectively and efficiently through these all of these annotations. So that's in a nutshell what I'm working on. There are some links beneath each of the institutions, but they have been put in blue, which makes it really bad to visible. So, but I show you they are there. You'll just have to change the color from in the presentation, or if I can do it myself, I'll do it myself. Thank you for your attention, and thanks for letting me speak.
Thank you. All right, up next is Aaron Max talking about chronophage. There we are.
Hello, everybody. I am going to be answering 3 questions in the next 5 minutes. First of all, what is the Cockle database? Second, why am I talking about it here at the IIIF conference? And third, who is that creepy looking monster? But only if I have enough time. So what is the Cockle database? Well, it is short for the Corpus Calendarium. It's a relational database of the devotional calendars from books of hours, manuscripts, which allows one to browse, drill down and analyze saints and calendars, and to make discoveries from the calendars. It is freely available online at the URL below. But what does all that really mean? So I take the devotional calendars from books of hours. I transcribe them into CSV files. I load them into a relational database. Yes, I did try to find the most complicated diagram for all of you guys. Once they're in the database, they can be browsed and filtered through a web UI. So here what we see are all of the manuscripts I know about, which were made in Italy, who have calendars in Latin and are currently held in Massachusetts. Once you pick those, you can compare the calendars side by side to do analysis and other comparisons. If you have a particular saint in mind, you can use that as the starting point for analysis. Here we have all of the entries that I know about for Saint Adrian. His official feast is September 8th. We get things like a distribution graph by date. Sometimes he gets demoted to the 7th or demoted to the 9th when a more important saint shows up, or when the scribe is screwed up. And we can also do a little pie chart of rank, because this is all data, so we can do data analysis with it. But But what does all this have to do with IIIF? So I am a consumer of IIIF. I am not a producer of IIIF. I predominantly use the digital facsimile images of the manuscripts to do my transcription. And this workflow is easiest and most efficient if I can download the images or if I have a constant UI. IIIF gives me both of those, and I get to pick and choose how I want to do it. I can either use a little tool that I've written that scrapes through the manifest and downloads the images I need, or I can throw them up in the browser of my choice and set up my workflow and do my transcription. To give you an idea of how much IIIF data I've used, this is a distribution of how I have accessed my manuscript. So the double crazy donut chart of doom on the far side shows that most of the manuscripts that I've transcribed, the blue section, were done digitally rather than in person. The tiny, tiny green wedge is for old school printed facsimiles, which are a thing that they used to do with manuscripts and kind of don't do anymore, but they're still out there. So of the manuscripts that I have, 87% were transcribed from digital copies, 10% from the original, and the other 3% from other sources. Of the digitized manuscripts, 38% come from IIIF-enabled repositories. However, only 28% of the repositories actually use IIIF. So the IIIF repositories are a more efficient way for me to get my data. In addition, if I eliminate two repositories, Walter's Art Gallery in Maryland and the sort of global OPEN collection that covers the Philadelphia area libraries, the percent of manuscripts transcribed from IIIF jumps to 50%. And the reason I eliminate those is they don't provide much of a UI at all. They just give you a directory of images. So for my goal of just downloading images, they are no harder than IIIF. So why does all this matter? And if we have time, what's the creepy thing? So all this matters because you as providers of IIIF are giving data to people like me. And I wanted to give you an idea of how all those images and how all that metadata gets consumed into other digital humanities projects, like our friend the Cocko database. And finally, what's this creepy thing? Well, this is called the Corpus Christi chronophage. It is a very complicated clock that was built at Corpus Christi College, Cambridge by a fellow named John Taylor. And I chose I chose her. She is referred to by the students as Rosalind. I chose her as my mascot for today because she eats time. And as this project, I consume hours. Thank you very much.
Glenn, can you get that off the screen, please? No, love it. Thank you. Happy to welcome next Leander Seige to talk about Detect IIIF, kind of a new iteration on browser extension.
Yes, thank you very much. I'm glad to have the opportunity to give some updates on the IIIF browser extension called Ducatteeuw. In the past years, I worked on several IIIF-related applications, like, for instance, the toy Antlitz Ninja, or the storytelling app Strollview, or the smartphone cover DIY app Cover Boutique, which I had the pleasure to work together with my daughter, Matilda. She's here today, and I'm very happy about it. Thanks. So, and when I worked on these projects, I often wanted to find nice and interesting IIIF content, of course, and some of you may know the situation. You explore an interesting repository with nice items in it, and it feels a little bit IIIF-ish, but you can just find the IIIF manifest link. Maybe it is hidden in some pop-up window or in another metadata page somewhere. And so I thought to myself, it would be nice to have a browser extension to scan the web pages I'm looking at for IIIF resources. And this was the moment when I invented the first version of the browser extension Detektiv. Detektiv intercepts traffic and also scans the content of the current web page in order to find IIIF resources, and it also checks for the existence or absence of important interoperability features of IIIF resources, just like the CORS, headers, SSL encryption, or whether the URL and the URI are identical, which can be very important in some cases. Detektiv also allows you to collect your IIIF resources in one basket and later export your basket as a IIIF JSON-LD collection, or to post it to another IIIF application of your choice. For me, it turned out, and I really learned about it when I used my own browser extension, that such a browser extension could help to standardize the handling of IIIF resources for scholars with less technical background knowledge and help them to overcome technical hurdles. The next big vision that I would have for Detektiv is actually to run a workspace application like Mirador, not from a server, but directly from within the browser extension. And I'm glad that I can report that a first proof of concept already was successful. I was able to manage that the basket in the Detektiv was real-time synchronized with the resources tab in Mirador, for instance. And then it would be possible to store annotations, not on some annotation server, but for instance, in the local or in the sync storage of the browser, and maybe persist it on GitHub or another suitable system. In this case, we could have a complete serverless research environment just inside the browser as a browser extension. For now, Detektiv is a browser extension that works with Chrome and with Firefox. It is, I consider it still to be in public beta state. It's open source, GPL licensed, so the code could still be improved. If you can spare some time and join me to improve Detektiv even more, then I would be happy about it. Check out detektiv.net to find all the necessary links and updates. Detektiv 2 is also available since, I think, yesterday on the Chrome Web Store. So you are invited to check it out and give it a try. And I'm quite sure that it will not buy cars in your name or cancel your flights. Detektiv is also usable as an institutional tool, so it's highly configurable and themable. And the first institution to provide a customized version of Detektiv for their institutional users is the Central Library in Zurich. And that's not a random coincidence. The Central Library in Zurich actually approached me, took the initiative to ask me to develop Detektiv even more, and provided the necessary funding for it. So I invite you to watch the next talk after the lunch break from Anna and Elias. They both will report on how they reached out to their scholars using IIIF, and the Detektiv extension will also play a role in this talk. And my second recommendation is the online workshop Mirador as a workspace, June 27th in cooperation with Stanford University Libraries, Leipzig University Library, and the Central Library in Zurich. Thank you very much for your attendance. Check out Ducatteeuw, follow me on Twitter, here are all the links. Thank you.
Thank you, Leander. All right, Glenn's going to get this last one set up. This is our last one, and this is something of a tradition, IIIF conferences. This comes from Tristan Rodas at COGAP, who has a lightning talk or a series of talks called Fun with IIIF. And I haven't seen this, but I've been warned that I think he recorded it a bit sped up in order to fit in all the fun IIIF projects. So just to end our hour on hard mode, this is Fun with IIIF. And then as a reminder, we're going to do a quick picture before we head off to lunch. So join us on the steps outside after this.
Hello. No time for intros, only time for fun. 30 projects, 6 minutes. Let's do this. Let's do it on fast forward. First up, we've got image tile puzzles by Mike Appleby from YCBA. You can select an image. Once you select that image, it loads up into a scrambled view, and you use your mouse to drag all of the pieces into the perfect place to reform that picture. Love it. Next, we've got a project from my colleague John. It's called the Transcriptomator, designed to run on an actual arcade machine in the British Library. The idea is to correct all of the broken transcriptions, and there's over 2 million pages to do it, so it takes a while to win. Then we've got the David Rumsey map tab. This is a Chrome extension where every new tab you open gets you a clickable, zoomable view of one of the maps from the collection. Incredible. In a similar vein, we have got the Art Institute Chicago Art tab. Every time you open a new tab, you get a new piece of art to view, and if you click on that piece of art, you get to see the full details in their online collection. Great. Then, next project. This is IIIF Gallery, an open Sea Dragon viewer that is a composite of different photographs to make it look like you're in an actual art gallery. You can zoom right in and even read the wall labels. Then we've got jigsaws. This isn't technically IIIF, but you can use any IIIF image online. You can download it. I'm using the same one that was used in the tile puzzle. You can then save your file to your computer and upload it to jigsawexplorer.com, whereupon you get yourself an online draggable jigsaw of the image that you've selected. Great stuff. Now, an experiment in surveillance, again by my colleague John White. This one is a nefarious app that allows you in the control room to view exactly what other people are doing as they innocently in their own browser scroll and pan around different artworks. We've then got the medieval makerword. So this is a project by Ben Alberton, and the idea is that he's taken carefully cropped versions of illuminated letters from medieval manuscripts, and you can use this as a palette and drag all of the different letters up to create a word of your choosing. Back to maps, another use of the David Rumsey map collection created by Jack Reed, and this time it runs on your Apple TV, so you have a nice slow Ken Burns zoom or pan around high-resolution maps in your very own living room. Here's a great project by Leander Seige. It's called Exquisite Corpse, and in it you can load up to 3 different parts of faces from different portraits and mix and match them until you create the most beautiful or humorous composite face of your choosing. Into space now, we've got 3D Trade Cards Explorer. These are trade cards from the Boston Public Library just down the road, and they've been digitized in high resolution. We put them into space and allow you to zoom around with a mouse or with your VR goggles on. You can turn around and go back the way you came in order to be able to read the writing on the back of the cards. Completely different now, here's some fractals created by Sean Martin. This is actually a programmatic use of IIIF in that, as we know, fractals never end. So you can zoom in and in until basically you hit the computation limits of the Open Sea Dragon viewer. It's approximately 25 billion pixels, so well terapixel. Now we've got me pretending to be Harrison Ford. Here we go, and I'll share the computer audio. It's a voice controlled computer. I'm telling the custom viewer to do what Harrison Ford did, to pan around an image and to display it on this pretend Esper machine in our office. It's a project by Danniau from the National Library of Wales. It's a World War I wall. So this is using Open Sea Dragon viewer in composite mode, collection mode, where we have hundreds of different images from the First World War all together on a huge high resolution touchscreen television. This is slow looking. And this is a project we created at COGAP in which you can load any IIIF image. And once you've loaded it, it will go into full screen mode and just slowly zoom in to the highest resolution and then pan around the image for a very calming, contemplative experience of your IIIF artworks. Here's a lovely project by Digirati, created for the Welcome Collection. And this is the story quilts. This was a physical object, which they then photograph in high resolution and allow you to navigate around it, viewing all of the different panels. Another project from Leander Seige and his daughter Matilda. This one is called Cover Boutique, and you can use any IIIF image to create custom artwork for your phone case. So you select the model phone, it will load up a template for the case, you select the image you want, and then you can place it, crop it, or composite it to create beautiful artwork you can then print out. Talking of art, here is some generative art by Jeff Stewart from Harvard Art Museum. This is called Art Forest, and on the left you can see he's selecting areas of an image, and the areas selected then turn into generative art trees that slowly grow up on the right-hand side of the screen. We've got Anona by Nikki O'Neill. This is a fantastic toolbox of different ways to view and annotate your IIIF images. So we have one mode where you can move around and zoom from point to point on different parts of the image, and you can see all of those annotations at once there. But there are also different ways to use it, in this case, to toggle images on and off for examples where the original part has been cut out of them. And here we've got twin browsing, so parallel zooming and panning of a photograph and a map at the same time. This next one, a new entry for this year from my colleague Satirius. This is the primary source ransom note generator. Using the IIIF search API, you can type some words and find examples in historic documents. It's also fully multilingual. So here he is typing words Ramadan Kareem, happy Ramadan, and it is finding those in scanned Arabic documents from the Arabian Gulf Digital Archive. Over to a project from the Getty. This is Animal Crossing. Here you can select artworks from the Getty's vast collection, crop them down to the areas you want, and then get yourself a tiny pixelated rendition that can be used directly within the Animal Crossing game by scanning the QR code. Next project, Infinite Zoom. I made this for a hack day a few years ago. You zoom into a picture, in this case, one of Tom Kramer with a selection of last year's memes, and every pixel you zoom into will then try to match and find images of the same color from the vast collection of different images from the Internet Archive. Another project from Jeff Stewart. This one is it uses Manifesto and D3 and Socket.io to be able to allow you to create your own artworks from selection of other artworks. So here you can see him selecting from the artwork on the left to create a palette of different shapes, which is then combining to create some sort of strange owl bird monster. This project is Stories, which we created at Foket to allow you to annotate any IIIF image, in this case, a map of subterranean London created by the artist Stephen Walter. And once you've annotated different regions, there's a simple online viewer. As you click forward and back, it will move you around and zoom you in to the particular part of the image that you want to look at. Next project, Mirrorama. This is taking a Mirrorama and adding IIIF. So here, these are scanned Mirroramas from various collections, and by hitting rebuild, you see every time you mimic the physical activity of mixing the cards. This is a project from Gareth Dash Nelson from the Boston Public Library, and here you can see an excellent way to synchronize video and images. He's giving a tour of a transit map of the New England area, and as he talks, the image underneath will move to highlight the areas that he is talking about. It can combine multiple different images and also let you explore freely. Next project, ArtGIF. Here we use the Art Institute Chicago Collections API to be able to select different images and combine them in a GIF. So here we're picking several different coins, cropping and zooming into the parts we want to, and at the top right there, you can see that each frame is then turned into a different frame of an animated GIF. Then one project showed that you don't need to be an expert. This is created by Ben Baccalar, and it's adding an animated GIF to Thomas Edison paper. And finally, you can just use plain Mirador. This is a great example by Kelly Davis of the Getty, saying taking two different game for us and allowing them to do side-eye. So there we go. There's the credits. Thank you to all of these people. Here are some links. I know this was fast, but there's a hyperlink. Thank you very much, and goodbye.
So you caught all that. Great. And we'll have the links in that, and he has the links to all those projects available. Let's, if you can join us out on the steps, we'll take a quick photograph just to commemorate the conference, and then we'll come back here at 1:30 to start again.